offset. Exactly at which point does it starts serving memory and allow us to reach EIP. So for that, we simply use it's a really makes life a lot easier, this MSF pattern, but we don't want to get the offset. We want to create a sequence of, let's say, length of 700, because we know that at 700 the machine crashes. So once we get this, let's just go there and try to enter that this code manually. After that, we're going to use the script, I promise. So before that, it is going to have an issue because it's paused. So let me just create a new instance of this machine. That's one thing you'll have to keep doing because we keep crashing it, so we have to let it run again. Now if I run this, it's gonna crash, but this time it's gonna help us identify exactly at which point does it crash. So now we get this EIP number. So we can use MSF pattern, but this time we're gonna use the option offset, and we're gonna give it that, we're gonna tell it that at length 700, when we use that, we got an offset uh, value of 35724,134. 35724,134. Let me double check that, and we're good to go. So it tells us that the offset is at 524. So that means that anything after 524 is going to be written to the EIP. So now again, I'm going to write an exploit, and let's just remove this part, and let me just change the variables over here. So it's dot 3. The offset we found out is 524. So now what's going to do, it's going to create bytes. So we have to add a b in order to get bytes, not strings. It's going to create 524 instances of this variable, and then what we want to identify if we're able to successfully reach that point, and we're going to give it b. B is saved as 424242 in hex. So then we'll know that we've successfully identified the uh, right portion. So let me just so this code, again similar to our fuzzying machine, does the same things. It connects using the socket.af.inet. That's the IP, that's the port. It connects, it receives the message, and then it sends our own code. So it's going to send the overflow, and it's going to send the return, that is the b's. And this value is basically how to press enter, because as you saw, simply entering those string in brainpan didn't work. We had to press enter. So in order to tell the Python code to press enter, we give it this, and then simply going to give the run, try to see if it doesn't run. It's going to tell us that it's disconnected, and finally it's going to close. So now if we save this, and I'm gonna check if the machine rerun that machine brainpan. I'm gonna open this, and once I run the code, I'm hoping that I find 42424242 in my EIP. So if I come over here, I'm gonna clear this for good luck, and I'm going to Python. Okay, and one more thing I want to do, because I wrote this previously, I'm gonna save it, save as to my new YouTube brainpan. I'm going to save it right here as an exploit. So now I can access it from this directory. I ran this and it should have crashed the application. It did. And as you can see, okay, so for some reason our EIP wasn't really, it didn't work, but let's see why it had an issue doing that. So if I come back to my code, we told it to, we gave it the offset, we gave it the IP, told it the return was that, it's going to give it the overflow. Let's see, because now it's saved in the right place. Should work now. Let me see if it's running. It's paused actually. Okay, that's why I didn't run it. You have to press run twice. Let's see. It's paused, and as you can see, we've successfully given it an EIP of 424242. So the next thing we want to know is to get the return address where from, so that we can send it a payload and redirect it towards us. In order to do this, what we have to do, we're gonna send it some bad characters, and first we have to ensure that this software, we accepts all characters, and if there are any bad characters specified, we don't send it that. So I already have a bad characters script, and it's a simple script which runs and gives us an output from 1 to 256 and every form of the code. So I'm gonna come here, and I'm simply going to say python 3 cd again, that because it's saved uh, at oscp buffer flow and bad chars. Here we go. So we have these bad chars, and let's just put that as our payload. So let's just go back to our exploit, and this time let's remove this, and let's just insert these bad chars as our payload. So again, that's going to be in bytes, and then we place it there. And before we send this, we want to ensure that it's included in the code. So we're gonna specify what to send, and here we go. So if I run that again, now before I run this, I want to make sure that there's a byte array that it it has. Okay, so let me run it first, and then I'll come to that part. So I ran it, and it's running. So now if I send this, we're there. So now we have to see if there were any bad characters. The first thing you want to do is you want to set this, you want to send Mona to its working directory. And you can do that by Mona config set working folder, C Mona, and wherever this name of the file is, because the other files there too. Once we have that, we want to create a byte array to which we have to compare our code with, and we're gonna specify not to include the null byte, which is 00, which doesn't work. We know that. So now it's created that. Now we can compare it with our own byte array, and to compare it to what, we're gonna come to our CPU, and we want to compare it with this new ESP, and let's see. Okay, so again, this is important to note that I sent it to the wrong place. Okay, so good. You see there are no bad characters in this uh, code we sent, so that's good. So our bad chars worked. So now all I have to do is, okay, I shouldn't have closed it down. That's a mistake on my part. And now we want to find the jump ESP. So for that, you can simply write Mona jump our ESP. This shows us where it's vulnerable, and where we can which part of this application can we exploit and inject our own harmful code, which it will execute and come back to us with. So as you can see, if we go to the log, we see that this 317712F3 has meets all the criteria, we want all of these to be false. Like uh, it's good for all of these are false, we know it's going to work. So because the code is 311712F3, uh, we'll have to write it as F3 12 17 31 because it reads it backwards. So this is going to be our return address. So let's go back to our code, and this time instead of B's, let's give it a return address of, it was um it was F3 12 17 31. This is the proper return address. So now if I know if this address I send it anything after this, it will execute. I want some layer of padding to be there so that it doesn't confuse the return address to the payload. So that's why I'm going to add a simple padding of digits around 32 bytes of my own, and then the payload. One thing that I like to do is play around with to see if the machine will actually work, and let's try if we can execute a calculate